Hey guys, one key and cardinal area in the whole of chemistry that is very fundamental and we need to hold it tight as far as Jamb And Waec is concerned is your mole concept and Avogadro'S number. They will never, ever play with it. And of course, this class is our lesson 16, right? Oh yes. So in this lesson 16, under your mole concept and Avogadro'S number, what should we know very fast? Let's start with mole concept. Let's go. First, I'd like you to note this. Just know that the term mole, right? What does it refer to? Anytime you just hear the word mole, it's talking about the amount of a substance. So mole just means what? What does it mean? Like basically, it means the amount of a what? Of a substance. And it is a unit of measurement in chemistry. Are you getting it now? So one of the major units for measurement in chemistry, what is it? Mole. It's a unit for measurement. So there are several other units of measurement. One of them is just mole. And the word mole is talking about what? Amount of a substance. For example, somebody decides to dash you, let me say, I decide to dash you now 1,000 naira, right? That 1,000 naira is an amount. And it has purchasing power to what it can buy. If I decide to, dash another person 5,000 naira, you see, one can do more, right? With respect to the amount, you can buy more compared to the other person. That means mole here, the mole that I've given the two of them, they are two different. Their mole ratios, let me put it that way, are kind of like different from each other. That's how we say that the term mole refer to what? Amount, not money now, but of a what? A substance. And what is it used for in chemistry? It is used for what? Measurement. But please hold this tight. Take note that the word mole is derived from a Latin word and it means heap. For example, you see farmers, right? By the time they are forming heap that they want to plant all those cassava or yam, you see the way they used to mole or heap or pile it. Are you getting it now? So the word mole is derived from a Latin word which is translated to mean heap or what? Pile. And very important, the symbol. Look at it. It is mole concept, right? But the symbol is M-O-L. M-O-L-E is the spelling for mole, but the symbol is what? M-O-L. Are you getting it now? Okay, if you understand this and you know that the symbol for mole, M-O-L-E, is M-O-L. Now, what is the definition for mole itself? Go straight. Tell us what a mole of a substance is. Tell us that a mole of a substance, right, is defined as the amount of the substance. You know, we said that the word mole means like amount of substance, right? So the mole of a substance is the amount of that substance that contains exactly, what does it contain? 6.022 times 10 raised to the power of 23 elementary particles. Two things you must hold tight. Number one, what is mole? It is the amount of a what? A substance. Now, what does it contain? It contains exactly 6.022 times 10 raised to the power of 23 elementary particles. And those elementary particles now can be in the form of probably your atoms, your molecules, your ions, your protons, or your what? Your neutrons. For the last time, tell me what is mole of a substance. The mole of a substance is defined as the amount of that substance that contains exactly what? 6.022 times 10 raised to the power of 23 elementary particles. And these elementary particles are either atoms, molecules, ions, protons, electrons, etc. Can I tell you something? One very important thing that is going to help you is that these definitions, you need to write them down. Like, right? You form short bullets. Write them down. Punchline. Start gumming them in various regions of your room. Are you getting it? Start gumming it if you are sharing a room with your brother or your sister. Gum it in your corner. Very, very important. As you are looking at the definition every day, what is forming? It is forming image in your mind. That there is image formation in your mind. Are you getting it now? And very soon, all of this will become part and integral components of you. So, for the last time, what is the mole of a substance? The mole of a substance is defined as the amount of that substance that contains exactly what? 6.022 times 10 to the power of 23 elementary particles. Those elementary particles are either atom, molecules, ions, protons, or what? Electrons. Now, the big question I would like to ask you, okay, sir, what is your 6.0223? What is it called? Now, here it is. this number that we call 6.022 times 10 raised to the power of 23 is called Avogadro's number. What is it called? Avogadro number. Come on, Avogadro number. Avogadro. Avogadro number. What's it called? Avogadro. What is the value for Avogadro number? 6.022 times 10 raised to the power of 23. 6.022 times 10 to the power of 23. 6.022 times 10 to the power of 23. 6.022 times 10 to the power of 23. Sometimes they may ask you, Jamb has never asked this, but you see it in some university post-UTME exams. Are you getting it now? Or scholarship exams, where they will ask you that the unit, right, for your Avogadro number is dash. The unit for it is 6.022 times 10 to the power of 23 what? Is it mole? Is it per mole? Is it liter? Or what is it? It is 6.022 times 10 to the power of 23 what? Per mole. Mole raised to the power of -1. So it is 6.022 times 10 raised to the power of what? Your 23 per mole. This is the value for your what? Avogadro number. If you get that very fast, share that account. Okay, you go jam for future. Now, don't forget this very quickly that specifically 1 mole of a substance, right, has the same number of elementary particles as you will see in exactly what? Your 12 grams of your what? Your carbon 12. So there are some relations. Like, in fact, everything about mole is your ability to think. As we are moving together, when we get to the calculations, if you are not following me in the way you are reasoning these things out, you go hear from my hand. Specifically, what did I say? 1 mole of a substance has the same number of elementary particles that you see in your 12 grams of your what? Your carbon 12. Okay, now this is it. Look at, for example, let's say we have 1 mole of magnesium atom, right? You know your magnesium, Mg, magnesium. What is the mass? What is the atomic number of magnesium? You know, magnesium is number 12 now. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium. Magnesium is number 12. That means the atomic number is 12, but the mass number. Atomic number is the down one. The up one is mass number. So mass number for it is what? 24. That's why you see 1 mole of magnesium atom, right, contains 24 what? Grams. Hold that one tight first. Another important thing you must know, in fact, all the elements, just know that whatever they have, right, where I told you that, let's say X is the element, A here is the atomic mass or the mass number, and then Z here is the atomic number. All elements, right, 1 mole of that element is an equivalent to its what? Atomic mass or the mass number. So it's very, very much okay and all right for me to also say this, that 1 mole of sodium will contain what? 23 grams. 1 mole of sodium will contain 23 grams. Yeah, sure, we are very correct. Okay. Let me not go far. When we get to past questions, I don't want to go. I don't want to rush, so that you'll be seeing them yourself. Please, for compounds, what happened in your compounds? 1 mole of a compound equals the relative molecular mass. RMM. 1 mole of a compound. Write it down. What is 1 mole of a compound equal to? It is equal to the relative molecular mass. Relative molecular mass. Or, you know that I told you that relative molecular mass is the same thing, is equivalent to your molar mass, right? And another name for molar mass is your what? Your formula mass. So it's very alright to say 1 mole of a substance is equal to your relative molecular mass, which is also equal to your molar mass, which is also equal to your what? Your formula mass. Give me the first I just said. 1 mole of a compound, right, is equal to your what? Your relative molecular mass, which is equal to your what? Your molecular mass or your molar mass. 1 mole, right, of a substance, what did we say is equal to? It is number 1 equal to your what? Your relative molecular mass, right, which is still equal to your what? Your molar mass, and then it is also equal to your what? Your formula mass, because molar mass is equal to formula mass, and then relative molecular mass is the same thing as your what? Your molar mass. So we can conclude therefore that for the last time, 1 mole of a substance is equal to what? Your relative molecular mass, which is equal to your what? Your molar mass, which is equal to your what? Your formula mass for that compound, right? Yeah, we will do the calculations. And don't forget this, that 1 mole of your calcium triazocarbonate, for how come that will say, okay, it is equal to 100? How? Follow me, let me show you. Don't forget that your calcium triazocarbonate, for it is your CaCO3, right? Which is equal to how many calcium there? 40 grams, right? Plus carbon is what? 12 plus oxygen, 3 atoms of oxygen into how many? 16. Multiply everything together now. That will give you 40, right? Plus 12 plus, what is 3 times 16? That should give you 48. 48, right? Yes. 48 plus 40 is your 88. 88 plus 12 will give you exactly what? 100. So we can say 1 mole of your calcium trisulcarbonate 4 is equals to what? 100 gram per mole, right? Because gram per mole is unit for molar mass. Let's go. Another important thing is this. 1 mole of your sodium hydroxide, how come that is equals to 40? Calculate it yourself now. Your sodium hydroxide, NaOH, sodium is what? 23 plus oxygen 16 plus hydrogen 1. That will give you 23 plus 1 is 24. 24 plus 16. What is 24 plus 16? That will give you 40 what? Grams per what? Per mole. That's exactly what you are going to have. So it's very okay to say that, okay, 1 mole of your CaCO3, calcium trisulcarbonate 4, it is equals to 100 gram per mole, which is the molar mass, right? Yes. Or 1 mole of your sodium hydroxide is equals to your what? Your 40 grams per mole, which is also the what? Molar mass or the formula mass. If you get all of these basic things, bro. There's what is called Avogadro number. Avogadro number. Come on, Avogadro number. What is the mechanism behind Avogadro number? What is it that controls Avogadro number, and what should we know before we go into calculations? First, I'd like you to know that 1 mole of a particle, right? And we said that that particle can either be an atom, a molecule, an ion, electron, or proton, right? It contains your Avogadro number. So when you just see Na, it's not sodium like this, or small capital N like this, and then small a underneath it. Please, this is Avogadro number. So small a underneath it like this, that's your Avogadro number. So we can say that your Avogadro number, what is the value for it? 6.022 times 10 to the power of 23, right? And then I told you that the unit for Avogadro number itself is what? Per mole. And very important, you must not forget this very quickly, that 1 mole of a gas, 1 mole of a gas, right? What is it equal to? It occupies a volume of 22.4 dm cube. 1 mole of a gas. Listen, 1 mole is the same thing as your 6.022 times 10 to the power of 23. This is in terms of particle. It is still okay to say, okay, oh sir, 1 mole of a gas, what is it equal to in terms of volume? It is equal to your 22.4 what? Dm cube, right? This is in dm cube. Are you getting it now? And 1 dm cube is equals to 1000 cm cube. If 1 dm cube is equivalent of 1000 cm cube, it means that we can say that 1 mole of a gas is equal to, multiply your 22.4 by 1000. What is it going to give you? It's going to give you 22,400 cm cube. So 1 mole of a gas, right, now is gas, not particle. The first one, 1 mole of a particle, what is it equal to? It will give you your Avogadro number, which is your 6.022 times 10 to the power of 23 what? Particles. But 1 mole of a gas, what is it going to give you? 22.4 dm cube, or 22,400 cm cube at STP, standard temperature and pressure. Okay. Another thing you must go tight is this: the volume that is occupied by 1 mole of any gas at STP. What is it called? It is called your gas molar volume. Follow me. What is the volume occupied by 1 mole of a gas at STP? 1 mole of a gas at STP at standard conditions of temperature and pressure. It is called your what? Your gas molar volume. Come on, gas molar volume. Gas molar volume. Gas molar volume. Gas molar volume. Come on, gas molar volume. Gas molar volume. 1 mole, right, of any gas at STP. The what it occupy, the volume that mole occupy, it is called your what? Your gas molar volume, and it has an equivalent of 22.4 what? Dm cube. Say that you call it 22.4 dm cube, or what? 22,400 what? Cm cube. Let me not talk much. Let's just rush and let me just give you some bass boost. Note 2 things. Number 1, 1 mole of CO2. Your CO2 is your carbon dioxide, right? 1 mole, and that CO2 that is carbon dioxide is a gas. We said that 1 mole of a gas occupy what? 22.4 dm cube, or 22,400 cm cube, right? And again, very important, don't forget that 44 grams of CO2. Okay, how do I know that CO2? Where is 44 grams coming from again? Carbon now, bro, now 12 EB plus oxygen is 2 into oxygen is 16. That will give you your 12 plus how many? 32. And that will give you 44 grams per mole. That's how we got it. So we can say that 44 grams, right? That's the mass of your carbon 4 oxide at STP occupy 22.4 watts dm cube. You must know these, their interconversions. When I solve 2 questions, you don't get all. You don't understand that. Another thing very quickly is this. Okay, 1 mole of your methane is a gas at STP. We said that 1 mole of a gas at STP, what does it occupy? It occupies what? 22.4 dm cube or 22,400 cm cube. So, okay, now your methane, get me the molar mass of methane. That will give us carbon is how many? 12 plus 4 into hydrogen is 1. That will give you 12 plus how many there? 4. That will give you how many? 16. So we can say that 16 grams, right, of your methane at STP, what will you occupy? 22.4 watt dm cube. Very important. Listen, this Jamb, if you try me, anything that make you to square anything less than 350, just try me, may you see. Just try me. No, now, at here, you just try me, may you see. The least is 350 that you must get. So let's go together. Don't forget this very quickly. Your Jamb 1981 question 13. Let's wire the past question very fast. Nothing is hard here. Jamb 1981 question 13. Look at the important sweet question. The number of atoms in 1 mole of a substance, what is it equal to? The number of atoms in 1 mole of a substance, what will it give you? Is it atomic number, or it will give you the Avogadro number, or it will give you the gas constant, or it will give you the number of electrons? The number of atoms in 1 mole of a substance every day is equal to your what? Avogadro number. The number of atoms in 1 mole of a substance is what? Avogadro number. And that makes option 1 the correct answer. You are out of there. No stress. Okay, sir. Wire me 1990. Question 4. Jamb past question. And Jamb brought this question. The question says, the Avogadro number of 24 grams of magnesium is the same as that of the Avogadro number of 24 grams of magnesium. What is it same as? Option A, let's see what they gave us. Option A say 1 gram of hydrogen molecule. 1 gram of hydrogen molecule. B says 16 gram of oxygen molecule. C says 32 gram of oxygen molecule. And then this is 35.5 gram of chlorine molecule. Follow me from here. Come. The Avogadro number for 24 grams of magnesium. I told you that magnesium Mg, right? 12. Here is 24, right? And that's how we got the 24 grams. So normally now, we can say that 24 grams of magnesium will contain your what? Your 22, that's your 6.022, right? Okay, follow me. We can say that your 24 grams of your what? Of magnesium, what will it contain? It will contain 6.022 times 10 to the power of your what? Your 23 particles, right? Yes, because your 1 mole of magnesium is what? 24 grams. Listen, 1 mole of that magnesium may be 24 grams. Okay. Yes, option A says 1 gram of hydrogen molecule. That means the Avogadro number, that means your 24 grams of magnesium will be the same thing as, is it the same thing as 1 gram of hydrogen molecule? No, sir, you are wrong. Come, you don't know why. Let me explain. Your hydrogen molecule is H2. It's different from atom of hydrogen. H is atom, right? But H2, please tell me now, what is the mass that should be in H2? Will it not be 2 times 1? Yes, 2 times 1. That will give you 2. I wish here were to be 2 grams of hydrogen molecule. We give you 24 grams of magnesium. You are correct if it were to be 2 grams of hydrogen, but 1 gram of hydrogen, no, you are wrong. Option B says 16 grams of oxygen molecule. 16 grams. Now, this is it. Oxygen molecule is O2. O like this is atom of oxygen, but molecule of oxygen is O2. And a molecule of oxygen will contain 2 times oxygen. Now, is it not normally O and then 16 on top of it? 2 times how many? 16. That will give you what? 32 grams. So, oxygen molecule contain 32 grams. So, 16 grams is wrong. 32 grams is making sense there, correct? And this is 35.5 grams of chlorine molecule. Follow me. Your chlorine molecule is your Cl2. This chlorine is diatomic. Hydrogen is diatomic. Oxygen is diatomic. Chlorine is diatomic. Chlorine, right, is diatomic. And that will give you 2 times what? 35.5. 2 times 35.5. That should give you 71 grams not 35.5 grams of chlorine molecule. No, it is not true. This is also wrong. The reasons are, I don't even know why are we really wrong. It's because they have written molecules. Molecule is different from atom. Are you getting it now? So now, if molecule is different from atom, please catch this with me. One molecule of your hydrogen contains 2 atoms of hydrogen. One molecule of hydrogen has 2 atoms of hydrogen, because hydrogen, let me erase so that we can have space and then we can solve more. Let's go. Catch it. One molecule, right? One molecule of hydrogen. This is it, how it is written. It contains what? 2 atoms of hydrogen. One molecule of oxygen contains 2 atoms of what? Oxygen. One molecule of chlorine contains what? 2 atoms of your chlorine. Are you getting it now? So what is the answer from the explanation I've given? Option C is the what? Correct answer. Jamb 1990 question waiting for. You don't get and you don't go. Pure. Simple. If you understand that very fast with me, please understand this again as I draw your ears to it. Don't forget this, that the molar mass of magnesium, right? What is it? 24 grams per mole. And your 24 grams of magnesium will correspond to 1 mole, which we have explained. And the molar mass of oxygen, O2, is your what? Your 32 grams per mole. And as a result, since each oxygen atom has a molar mass of 16, right? So you just multiply that 16 by 2. That's why I'll now give you your oxygen molecule. And from there, you can now say that, okay, 32 grams of oxygen will also correspond to what? 1 mole of your what? Your magnesium. That's all you're out of there, bro. You get that very fast. Look at Jamb 2002 question 5. Jamb 2002 question 5. They brought this interesting question. Which of the following gases, right, contains the least number of atoms at STP? Which of the following gases contain the least number of atoms, not molecule now, atoms at STP? Option A says 7 moles of argon. 7 moles of argon. Option B went ahead to tell us that 2 moles of chlorine. Now follow me, come. 7 moles of argon. First and foremost, argon is Ar. Argon is what? Monoatomic. And because it is monoatomic, we can say that, okay, 7 mole of argon, right, will contain, what will it contain? 7 times 1, right, which is equal to 7. Then you can now go and multiply by your Avogadro number, which is your 6.022 times 10 to the power of what? 23. That's what I'm going to give you there. B says 4 mole of chlorine. 4 mole of chlorine. Your chlorine is Cl2. It is diatomic. 4 mole of chlorine. Talking about 4 molecules of chlorine. That is diatomic. And that will give you, chlorine is diatomic. What is your 4 molecules of diatomic? How many atoms do you have in 4 molecules of your chlorine? That will give you 4 times that 2 now, Cl2. That's 2. And that will give you how many? 8. So that 8 now will now be what we multiply your Avogadro number. And that will be 8 times your what? Your 6.022 times 10 to the power of 23. Now, look at option C. Option C says 3 moles of ozone. 3 moles of ozone, or 3 molecules of ozone. Ozone is O3. Ozone is triatomic. Sir. Your oxygen is diatomic. Ozone is your what? Triatomic. Look at it. Oxygen and ozone, they are the allotropes of oxygen. Hey. Allotropes is different from isotopes. Under the isotopes of oxygen, what do we have? We have O16. Isotopes of oxygen, it is what? Oxygen 16, right? Oxygen 16, oxygen what? 17, and what? Oxygen what? 18. These are the isotopes of oxygen. As we get to oxygen and the compound, I will wire all of them where ozone is triatomic, O3. And since ozone is triatomic, what will it give me there very, very fast? It's going to give me nothing but your 3, right? Yes, that's, we say 3 moles of ozone, and 1 mole of ozone first is triatomic. So 3 mole of ozone will be 3 times 3, right? That will give you 3 times 3, which is equal to 9 multiplied by 6.02 times 10 to the power of what? Your 23 what? Particle. Now look at option D. 1 mole of butane. Now but is carbon 4, right? Butane. What is the formula for butane? That's C4H10, right? That's the formula for butane. Butane, C4H10. This is under organic chemistry. I'll treat everything from beginning to the end for you in organic chemistry. Are you getting it now? So just be following the classes step by step before you get to organic chemistry. Now, 1 mole of butane, what will it contain? Of course, how many atoms are inside? You can see that from your C4H10, right? How many carbon? 4. How many hydrogen? 10. Altogether, how many atoms? 14 atoms. That will give you what? Your 1 mole of butane will give you 1 times 14. And that will give you a total of your 14 times your what? Your 6.02 times 10 to the power of your what? 23. Now, the question is, which of the following gases contain the least number of atoms? Bro, which one will contain the least number of atoms? Option A, 7 mole of argon is just 7 atoms that are there. 7 atoms that you now going to multiply by 6.02. 4 moles of chlorine has 8 atoms. 3 moles of ozone has 9 atoms. And 1 mole of butane has what? 14 atoms. So which of the following has the least number of atoms? Is it not 7? The one that is the least. That's 7 mole of what? Argon. Making option what? A, the correct answer. Very simple, easy, cheap, and direct. Does it make sense? Look at the next question very quickly. Question 4, which is your JAMB 2002 question 5. JAMB asks this interesting question, and the question says the volume of 2.5 moles of oxygen at STP is volume of 2.5 mole of oxygen at STP. What is it? Option A, 50 dm cube. B says 84 dm cube. We're giving 28 dm cube, and then option D is your 56 dm cube. Now follow me from here. We have established that 1 mole of any gas, right? Any gas at all. If you like the oxygen, or if you like the chlorine, or if you like the hydrogen, or be whatever you like, or in as far you are gas, 1 mole of any gas, what does it contain in terms of your dm cube? It is your 22.4 dm cube. Shebi, we have established that. Then the question now say the volume of 2.5 moles of oxygen. This oxygen does not matter. It can be any gas, right? So 2.5 moles, right, of that gas, what will it contain? X. So it's going to contain. So find the value of X. That's what the question is saying in dm cube. X is going to give you, just cross multiply. That will give you 22.4 times your what's your 25 2.5. 22.4 times 2.5. Ahead. Oh yeah, very, very fast. Wire me the answer. 22.4 times your 2.5. 2.5. What will it give you? 56 dm cube. 56 dm cube is the answer. And which option do you see that? Option D. Ha ha ha. She say cheap. Look at question 5, which is our last question before we go to the next class. Your JAMB 2002 question 5. In JAMB 2002 question 5, how many atoms are present in 6 grams of magnesium? How many atoms? How many atoms? How many atoms are there in 6 grams? I want you to reason it first. How many atoms? Atoms are there in 6 grams of what? Magnesium. Okay. Option A says, and they gave us our value of your magnesium Mg24, and they gave Avogadro number 6.02 times 10 to the power of what? 23. Please, whatever they give you is what you work with. If they give you 6.022, work with 6.022. If they give you 6.02, work with 6.02. And then option A, they gave option B, they gave option C, they gave option D. So we are going to solve and get our answer. How many atoms are present in 6 grams of magnesium? Can we solve it together? Now, this is it. You know, it's okay to say that your 124 grams, right? Magnesium is 24 grams, isn't it? 24 grams of magnesium is what we contain. What is the Avogadro number for it? 6.02 times 10 raised to the power of your what? Your 23 per mole. You can see that they even give me you per mole here, right? I gave you the unit of Avogadro number is what? Per mole. Now, the question says your 6 gram of magnesium, 24 gram of magnesium is what is giving us this. So what is your 6 grams of that magnesium going to give us? X is what it's going to give you. So find the value of X now. X will give you nothing but your cross multiply. That will give you 6 times 6.02 times 10 to the power of 23 divide by your what? Your 24. And X is going to give us very fast. Oh yeah, let's go. 6 times 6.02, right? Times 10 raised to the power of your what? Your 23. Whatever you have, go and divide it by your 24. And what are you going to have? It's going to give us nothing but your what? Your 1.505 times 10 raised to the power of 23. 1.505 times 10 to the power of 23. What is your 1.505? If you approximate it, is it not going to give you option C, which is your 1.51 times 10 to the power of what? 23. So what is the correct answer? Option C becomes the what? Correct answer. Are you getting it now? So if you get this very fast, you can see that all these calculations are very, very simple, right? Under your mole, we are looking at mole, Avogadro number, and all of that. If you understand this, bro, guess what? I'll see you in the next class. And in that next class, we're going to look at something like as we proceed and look at your formulas involving moles. Formulas involving what? Moves. There are 5 formulas involving moves. We look at all of them, look at their past question, look at one, look at the past question, look at another past question, just like that. How many formulas? 5. I beg you for one thing. Go to my notes at the end of the next class. Finish the next class first. That means formulas involving move. Finish that class first before you go into the notes. Are you getting it now? When you go to the notes, a lot of questions are there. A lot. Only you will answer all of them. The answers are there anyway. You solve them, run through them before you go to the next topic. I'll see you in the next class. Enjoy. Have that.